All right, so we'll start with 7.4. And it deals with quadratic equations. And y'all, quadratic equations come in the following form: ax squared plus bx plus c equal to 0. So what makes these quadratics are those x squared terms, okay? So two ways that we can solve these quadratic equations. One way is by factoring. Second way, we'll use the quadratic formula. So if I can't get something to factor, I'm going to use that quadratic formula because it'll work every single time. So the first thing I'm going to do is do a little review on factoring. And y'all, there'll be 4 different signs that can happen. If A, B, and C are all positive numbers, when you factor this, both of these will be positive. So if both your numbers B and C are positive, when you factor it, both signs will be positive. If the middle number's negative and the last number's positive, so notice my negative B in the middle. If I have a negative number in the middle and a positive number at the end, both these factors will be negative. So notice if the last number's positive, like the C's on both of these, if the last number's positive, both of these factors will have the same sign as that middle number. Now, if this last number is negative, one of your factors will be positive. One of your factors will be negative. Now, if the middle number is positive and the last number is negative, that means the positive factor will be the larger number. And the negative factor will be my smaller number in that case. Now, if both of these numbers are negative, the B and the C, you'll still have unlike signs. One will be positive, one will be negative, except this time, since the B in the middle is negative, my larger number will be negative. All right, y'all, so let me start back on the top. If I got all these numbers are positive, my two factors will both be positive. And what we do, we find factors of the C that add to get the B. So I'm going to find factors of this last number that add to get the number in the middle. So I'll do that on both of these. Since they're both positive at the end, I'm going to find factors of the last number that add to get the middle number. Now, both of these where the last numbers are negative, on these two, I'm going to find factors of C that subtract to get B. And remember, once I find these two numbers that subtract to get B, if the middle number is positive, the larger factor will be positive. If that middle number is negative, then my larger factor will be negative. So I'm going to run through a few examples on factoring before we start trying to play with these exercises. So what we're going to do, we're going to factor. So y'all, the first one I'm going to factor, how about an x squared plus 17x plus 30. So these are going to factor into two sets of parentheses. Since I got an x squared in the front of this trinomial, that means the only way to get an x squared is an x times an x. Now, both these numbers are positive, so we're going to follow the first case up here. And up here we said if they're both positive, both my factors will be positive. So we can get everything ready now. All y'all need to do is find me two factors of 30 that will add to get me a 17. So what two numbers multiply to get 30, but will add and get me 17? And so you can just start shooting through numbers. You got 1 and 30. Well, that adds to get 31.
7 and 10.
Oh, what'd y'all just say?
Seven and 10.
All right, but remember, they got to multiply to get 30. So remember, 7 times 10 is going to give you 70.
15 and 2.
Okay, because that would have been my next factors to try. So I did 1 and 30. 2 and 15, they multiply to get 30. They add to get 17. So I just come in and put my 2 and my 15, and we're done. So if you was to FOIL this, x squared, 15x, here'd be 2x's. So the 15x and 2x would get to 17, and then the 2 times 15 equal 30. So these two numbers got to add to get your middle, but then the two numbers got to multiply to get that last number. And y'all, if 2 and 15 wouldn't have worked, I'd have did 3 and 10, and then finally what, 5 and 6. So that's all the factors of 30, but the only ones that added to get 17 were the 2 and 15. Let's try this one. How about x squared equals, how about 10x plus 24? So once again, I'm going to set up my two sets of parentheses. I got an x squared in the front, so that's when I'm put an x and an x. So the last number is positive, so that means both of these will be negative like the middle. And y'all, that's what we set up here. If it's negative in the middle and positive at the end, both factors will be negative. Now, I still want factors of 24, so we need to find factors of 24 that'll add to get 10. So we got 1 times 24, that gives me 25. 2 times 12, that adds to get me 14. Next, I would try 3 times 8. That adds to get me 11. Next, I would add what? My last factor would be 4 times 6. And y'all, there we go. 4 times 6 is 24. 4 plus 6 equals 10. So I would put in my 4 and my 6. So now, -4 and -6, add to get a -10. -4 times -6 equals a positive 24. So if that last number is positive, find me factors of the last number that equal the middle number. And remember, they both have the same sign as the middle number. So let me throw some negatives at the end. How about if I had x squared plus x minus 20? So let's set our parentheses out. X squared is an x and an x again. This time, remember, since the last number is negative up here, we said if the last number is negative, we're going to have unlike signs. So one will be positive, one will be negative. So y'all, what I want now are any factors of 20 that when I subtract, get me a 1. Because remember, there's not a number in front of the x, you treat it like a 1. So I need factors of 20 that'll subtract and give me 1. So you can shoot through your numbers. 1 times 20, that gives me a 19. 2 times 10, that subtracts and gives me an 8. What's next? The last set of factors is 4 and 5. Well, notice 5 minus 4 gives me a 1. So my two factors will be 4 and 5 on this one. Now here's a trick. The larger of these two factors has to have the same sign as that middle number. So since that middle number is positive, the 5 will be positive, the 4 will be negative. So if you add this, 5 and negative 4 equal 1. 5 times negative 4 equals negative 20. All right, y'all, one more. How about a negative in the middle? So how about a negative 7x minus 30? So remember, both of these are negative. We said if they're both negative, you're still going to have unlike signs. So this will be an x plus and an x minus. So anytime that last number is negative, you got to have unlike signs. Now, can y'all find me factors of 30 that'll subtract and give me a 7?
Three and 10.
3 and 10, that's perfect. Now, since my middle number is negative, my larger number has to be negative. So the 10 will be negative and the 3 positive. So if you add that, 3 and negative 10 give you negative 7. If you multiply 3 times negative 10, you get a negative 30. So y'all, that's a trick on factoring, is just finding those factors that multiply to get the last number, but they add to get your middle number. Now, watch what I do on this example. This is an example of your homework here. So this will be your first one. They say find the zeros of the following function. So this will be like y'all's number one. And number one in the homework is going to be one that you can actually factor. And then the rest we'll learn how to do with the quadratic formula. So they got this. F of C equals C squared plus 6C plus 8. Now, finding the zeros in algebra means the same thing as finding the solutions, okay? So if I want to use this to find the actual solutions, I'm going to take the C squared plus 6C plus 8 and set that equal to 0. Because now we're not just factoring it, we're actually going to find the solutions. And what they mean by finding zeros is you set your equation equal to 0. And to start out, we're going to factor this. So C squared is going to put a C in the front, C in the back. Last number is positive. So both of these will be positive, like the 6 in the middle. So y'all, the question of the day, find me some factors of 8 that'll add to get me a 6.
2 and 4.
2 and 4. And it's nice when they're both positive. It don't matter where you put the 2, where you put the 4. So now that we've got this factored, to actually find the solutions, we take each of those factors and set them equal to 0. Because what we're invoking is the zero product rule. If this factor equals 0, then the whole thing is 0. If this factor can equal 0, then the whole thing will be 0. So y'all, we got to solve both of these, one step each. C plus 2 equals 0. I'm going to subtract 2 from both sides. And I get a C is a negative 2. Second equation, c plus 4 equals 0. I'm going to subtract 4. And I get c equals a -4. So my two solutions, now here's a trick. This biggest exponent, since that exponent is a 2, that tells me I need two answers. And there we go, -2 and -4. So if we can factor stuff, it's nice because we can get our answers really quick. And if you notice, the solutions always have an opposite sign than your factors have. If both your factors are going to be positive, your two solutions will both be negative, and vice versa, okay? All right, y'all, so let me flip the page, because not all of these quadratic equations are factorable. Sometimes they're not factorable. So when they're not factorable, we have to use what we call the quadratic formula. Now, before I get into the quadratic formula, I'm going to review y'all on simplifying radicals. And the radicals we're looking at are just these square root radicals. So there's some numbers we need to learn that we call perfect squares. Perfect squares are numbers. So let me see what the chat's saying. So someone's asking what lessons I'm teaching. I'm teaching 7.4 and 4.8 for college algebra. All right, y'all, perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. Oh, what's next? 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. Oh, I'll go a little bit further. 11 times 11 is 121. 12 times 12 is 144. And then finally, 13 times 13 is 169. These numbers are called perfect squares. That means you can take the square root of these numbers and get a nice integer. Like the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. And so on. Because that's what you need to know when we simplify radicals. So to simplify a radical means to remove any factors that are perfect squares. Okay, so if I got a number under that radical, it cannot contain factors that are perfect squares. If it does contain a factor that's a perfect square, I got to break those out of that radical, okay? So let's just simplify some radicals. Before we play with that quadratic formula, okay? So we're going to simplify the radical expressions. Because y'all, if you can't simplify the radical expressions, you'll never finish that quadratic formula because it's got a big, huge, gigantic radical in it, okay? So let's start out with, go mellow here. How about a square root of 25? So y'all, what number times itself equals 25?
5.
And what other number times itself equals 25?
No
Five
other
times 5. -5.
-5. So when we do square roots now, we're going to take into account that that can be a positive or a negative 5. So that's why I'm using this plus or minus for shorthand, because it means positive 5 times 5 is 25. It also means a negative 5 times negative 5 is 25. All right, y'all, let's try another one. How about 81?
Nine or
Mhm.
negative 9.
So that's going to be a positive or negative 9. All right, so now I'm going to throw the curveballs. I'm going to put a 20 under this. Well, y'all, 20 is not in this list over here. Well, that means 20 is not a perfect square. But here's my question. Does 20 contain any of these numbers as a factor of it?
4.
There you go. So what we would do, we would make this a square root of 4 times a square root of 5. So notice 4 times 5 still equals 20 under these radicals. But y'all, now I can simplify the square root of 4. So the square root of 4 will give me a plus or minus 2, and then bring down my square root of 5. Now notice the 5. Now 1 don't help us do anything, because when you take the square root of 1, you still got the number there. So don't worry about 1. We're worried about numbers like 4, 9, 16, and so on. Well, 5 does not have any of these numbers as a factor. So I know that the 5 is now simplified, so that my final answer is going to be a plus or minus 2 square root of 5. All right, y'all, how about if I threw a, how about a, I'll do a 50 under here. Does my 50 contain any of these perfect squares as a factor?
You could use 25 and 2.
So I'm going to do 25 and 2. Good job. All right, so now we broke the 25 out. Now we're going to take the square root of that 25. We'll get a plus or minus 5 square root of 2. So y'all, let me ask you this. In the real world, can I take the square root of a negative 4?
No.
Is there a number times itself that'll give me a negative 4?
No.
No, not in the real world. So what we do in this case, we're going to break out that negative 1. So we're going to make this a square root of 4 times a square root of negative 1.
Actually, I have a quick question.
Okay.
So I know you said that you would break out the -1, but would that not be considered I because of the imaginary?
Oh, it's about to be. So there you go. Because remember, I can't do this in the real world, so I'm going to have to do it in the imaginary world, right? Yeah. So we got a definition now. So we can take the square root of the 4. That's going to give me a plus or minus 2. But y'all, in the real world, we can't take the square root of the negative 1. So we replace the square root of negative 1 with a I. So on the calculator, that little I above the 0, I think it's above the 0 or the dot down there. That's what that is. That stands for, this is now what we call imaginary numbers. So imaginary numbers, I can multiply and make this negative 4, but in the real world, it's not happening, okay? So good job. That's nice that you remembered that. So y'all, this is how the imaginary numbers are formed. All right, so what about this? Can I do, how about a negative under here and maybe 18? So 18 doesn't have any factors that are perfect squares.
9.
9. So what I do when I got the negatives under here, I'm going to put my 9 first. Then I'm going to put the -1. Then I'm going to put the 2. And the reason we put the -1s in front of these radicals is so that when you write it in math lab, it don't look like the I is under the radical, okay? So watch what will happen. Square root of 9 is going to be a plus or minus 3. Square root of -1, we're going to replace with
I.
I. And then we can't do nothing with that square root of 2, so we're going to throw in at the end. And we just usually write the number, the I, before the radical stuff, okay? But you can put it afterwards, but just don't put it under that radical, okay?
I have a quick question. Can the I also go on the side of the square root? Not under it, but like by its side.
You can
Or
do
would it be
this.
better in front?
You can do it if you do, say, plus or minus 3, square root of 2, get out from under that radical, then put your I, okay?
So do you just add a -1 whenever there's a negative underneath the radical?
Exactly. When it's a square root, because we can't remember, like signs are always going to be positive. So anytime there's a negative, basically you can go to the shortcut and bring that negative out as a I.
Positive. Okay.
Okay. So now that brings us to the formula of the day. When we're not able to factor and solve a quadratic equation, we're going to use the quadratic formula. Now, you still want everything on one side equal to 0. Okay, we need everything on one side equal to 0. So if we cannot factor this, we're going to use the quadratic formula. And the way we get our two answers is the x will equal -b plus or minus square root. So notice they're now accounting for plus or minuses because these square roots can be positive or they can be negative. So that's the purpose of the plus or minus. And then it's b squared minus 4ac, all of this over 2 times a. So with this b squared minus 4ac, if that all ends up being a positive number, we'll get 2 real answers out of this. If the b squared minus 4ac ends up being a negative number, then we're going to get 2 imaginary answers out of this. So that radical determines whether I get real numbers or if I get imaginary numbers, okay?
I have a question.
Mm-hmm.
So on the homework, are we gonna have to do the simplify the radicals?
Well, not by itself, but some of these problems might have a radical when I'm working through them that I gotta simplify.
Okay, and one more question. When you do the plus and the minus sign in front of the number, are we gonna have to put that in for our answers on the homework? Is it gonna give us that option?
So that'll be, yeah, it's got the plus or minus. So that's shorthand. So what I use, if the plus or minus, I'll use that if the radical is still here. Now, if I can get rid of the radical altogether and just turn that into a number, then the plus or minus I'll use to get the 2 different answers. First time I'll come in, I'll add the top, then divide by 2a. Second time I'll come in and subtract the top and get divided by 2a.
Okay.
So yeah, we're about to start working on some of these and you'll be able to see what this is happening, okay? So y'all tattoo that on your arm because that's the formula of the day. All righty, y'all, so here we go. Let me turn my paper over, it's getting a little curvy. So this example is like number 2 on your problems. It says find the zeros of the following function. You know, the answers, it says simplify your answers, including any radicals. And then if we get complex numbers, I'll show y'all how to write them in terms of pi, okay? So this first problem is like y'all's number 2. Find the zeros. They got f of x equals x squared minus 2x minus 4. So the first thing is set this equal to 0. Now, there's no way I got factors of 4 that'll subtract and get me that 2. 2 and 2 subtract to get me 0. 4 and 1 subtract to get me 3. So this does not factor, so we will use the quadratic formula. So first thing is to figure out what these 3 numbers are. And y'all, I'll tell you, B is -2 in the middle. C will be -4. What is my A?
1 square.
Well, you don't even have to square it. You just need to put me a 1 there, okay? So just remember, if there's not a number in front of it, it's definitely a 1. So now we're going to plug this in. X equals negative. So the negative's in the formula. Then we put in our B, which is a -2. So this negative's purpose in the formula, its only purpose in life, is to change the sign of whatever our B is. All right, then we had plus or minus square root. B squared is a -2 squared. So I always put my negatives in parentheses because remember, a negative times a negative will be a positive. So B squared minus 4 times A, which is 1, and C, which is -4. All that over 2 times A, which is 1. So most of my work was going to be under that radical until I can start simplifying it. Only thing I can do on the outside is make that double negative a +2, and then I can make that 2 times 1 a 2 on the bottom. So a -2 is a +2 plus or minus. All right, y'all. -2 squared is a +4. Now notice, everything else over here, all that stuff is being multiplied together. You got 2 negatives on the right side. So 2 negatives is going to make that all positive. So -4 times 1 is -4. -4 times -4 makes that a +16. And then all of that over R2. All right, so my last step under the radical is to add that 4 and 16. So that's going to give me 2 plus or minus square root 4 plus 16 is 20, all divided by 2. So now guess what we got to do? We got a square root of 20 sitting here. We need to simplify that square root of 20. So I'm going to do some side work. And what we need to do is figure out whether we can simplify that square root of 20. So y'all, are there any of them perfect squares that are factors of that 20?
4.
So since 4 is a factor, I'm going to make that a 4 and a 5. All righty, y'all. Square root of 4 is going to give me 2. So I get a 2 square root of 5. Now remember, the quadratic formula's already got the plus or minus there, so I don't have to worry about it at this point. So I'm going to plug that 2 square root of 5 in for that square root of 20. So I'm going to get 2 plus or minus 2 square root of 5 over 2. Now, at this point, I'm going to try to simplify. So you got to look at all three of the outside numbers. Well, I got a 2, a 2, and a 2. Now remember, outside numbers cannot simplify with numbers under that radical. So you look at all three of the outside numbers, all three of those numbers will divide by that 2. So here we go. 2 divided by 2 makes that a 1, plus or minus 2 divided by 2 makes that a 1 square root of 5. So since I had a 1 in front of the square root of 5, I do not have to write that, okay? It's understood to be a 1 in front of that radical. So y'all, in MathLab, I would shortcut this answer by using the plus or minus, but the first answer would actually be 1 plus square root of 5. The second number, I'd use the minus, and I get a 1 minus square root of 5.
So we would have to write both of those as our answer.
Yeah, or use this plus or minus like it has here.
Okay.
Yeah, on these ones with the radicals, MathLab will let y'all use that plus or minus. It'll when you click on the answer blank and it pulls up that little bar on the bottom, it'll have that plus or minus for you. So this is doing some math here, right? All right, y'all. So the rest of these are going to be just using quadratic formula. So find the zeros of this function. I got x squared plus 5x minus a 7 equals 0. Now, y'all, this one wants me to use exact answers. So exact answers have the radicals. Then it wants me to use approximations. And approximations will be decimals. So they just want us to figure out both methods on this so that you can understand what kind of answers you're getting is if you was using decimals. And when I do the decimals, I'm going to round them. It looks like, let me see, 3 decimal places, okay? All right, so A, B, and C. So A is 1 again. B is 5. And C will be -7. So we'll get the radical answers first. That'll be the exact answers. And then I'm just going to punch them in the calculator and get my decimal approximations. So y'all, here we go. X equals -b, which is 5, plus or minus a square root b squared, which is 5 squared, minus 4 times a, which is 1, c, which is -7, all that over 2 times a, which is 1. All right, y'all, so I'm going to make that a -5 now, plus or minus. Well, y'all, 5 squared is 25. And y'all, here's the thing you got to remember also. Whether that number is negative or positive, when you square it, it's got to be positive, okay? Now, look over here. I got 2 negatives again, so 2 negatives is going to make this positive. And then let's see what we get. 4 times 1 is 4. 4 times 7 is 28. All of that over 2 times 1, which is 2. All right, final step under the radical is to add them together. So y'all, I get a -5 plus or minus 25 and 28 give me 53 all over 2. So now side work is working on that 53. So y'all, are there any factors that are perfect squares that are factors of that 53? So will it divide by 4? Probably not. Will it divide by 9? No, 9 and 6 is 54, so that don't work. What's next? 16 was not divided by 16 because it's not even an even number. 25 won't divide into that because 25 and 2 give me 50. So y'all, guess what? There's no factors that are factors of 53 that are perfect squares. So this thing does not simplify. So since this radical does not simplify, this right here is my final answer. -5 plus or minus square root of 53 over 2. So this is the exact answer they was wanting first. Now to get the approximations, I'm going to go to the calculator and I'm going to use the fraction form. So maybe remember to make it a fraction, let's go to the calculator. So remember to get the fraction, I'm going to hit alpha y equals because that brings up the fractions in D. So I'm going to hit enter. So now this will look like a big fraction. So notice on top I had -5. Now we're going to have to do one answer at a time. We can't do both the plus and minuses on the calculator to get the two answers. So the first time I'm going to do it, I'm going to add the square root. So come down here and push the blue button and the x squared button, get the square root. Under the square root, we had a 53. Now I'm going to arrow to the bottom and put my 2. And y'all, if you look at that, -5 plus square root of 53 over 2. I'm going to hit enter, get my first answer, and we're going to round this 3 decimal places. Whoops, let me see what I did. Oh, my bad. I must have hit the subtraction instead of the negative. All right, so use the negative key on the 5. I think I hit the wrong button. Now let's hit enter and go 3 decimal places. So this would be what? 1.14. So the third decimal place is 0, but it's got a 0 after it, so it's going to stay a 0. Now, if that second 0 would have been a 5, 6, 7, 8, or 9, I would have rounded that 0 into a 1. All right, y'all, I'm going to go to alpha y equals again, get my fractions again. This time I'm going to do -5 minus square root, which is second x squared. Put my 53 under there. Then I'm going to arrow down to the bottom and put my 2. All right, so this is the one being subtracted. Let me hit enter. So notice this one, I get a -6 point. And if you notice, the decimal parts are usually about the same on these. So that's going to round to what, a 140, since the second 0 is less than 5. So that's going to be a -6.140. But y'all, if you want to, let me show y'all a little trick on this. If you sort of suck at rounding numbers, watch this. This mode button, I'm going to hit the mode button. And I'm going to arrow down where it says float. Float means it's going to put all the decimal places. But if I'm going to round 3 decimal places, I can go click on the 3 and hit enter. So now my calculator is going to round everything 3 decimal places. So watch what happens when I hit enter on this. Bam, there's that -6.140. So if you want to round, just click mode and go down here to float and arrow over to 3. That's how many decimal places this thing will round it off to, okay? And then you hit clear and go back to your screen. All right, y'all. So my exact answers were the -5 plus or minus square root of 53 over 2. My decimal approximations 1.140, -6.140.
At the beginning where you put -5, why did you put -5 instead of 5? Because
Okay, because remember, here's our quadratic formula. It is -b.
oh, I see now. I
Uh-huh.
see.
So this negative is always in the
It was gonna be
formula.
negative. I see. Thank you.
And its only purpose in life is to change the sign of whatever this b is. So if that b is a 5, it's going to change it to a -5. If the b would have been a -5, it would have changed it into a +5. All right, y'all. F of x is going to equal 3x squared minus the x plus a 4. So first, let's figure out our A, B, and C. So A is a 3 this time. So what are y'all putting for B?
-1.
All righty, and then C is 4. All right, y'all, so let me plug all this into our formula now and see what we get. X equals negative B, which is a -1, plus or minus our square root. B squared will be -1 squared minus 4 times A, which is 3, and C, which is 4. All that over 2 times my A, which is 3. All righty, y'all. So let me pull my camera down just a little bit for this one. So the -1, that's going to make that a +1 now. Plus or minus. All right, so let's see what we got under our radical. -1 squared is a +1. Now, y'all look at this. This right side over here, I've only got one negative, so that's going to stay negative. And then let's see what we got. 4 times 3 is 12. 12 times 4, that's what, 48? All that over 2 times 3, which is 6. All right, I guess I can actually finish up under my radical now. So I get 1 plus or minus square root 1 minus 48. Woo, that's going to give us a -47 all over R6. So we're going to play with that radical real quick and do our side work. So I got a square root of a -47. Can I simplify that? And I will say there is that at least one thing I will do to that. But let's see, 47 is not dividing by 4. It's not dividing by 9. It's not dividing by 16. It's not dividing by 25. It's not dividing by 36. And everything else is too big. So you can't separate that simplify that 47. But y'all, you can do something about that negative. What are we going to do about that negative?
Times it by the square root.
Well, you're getting a little complicated. That's too much. All I want y'all to do with that negative is bring it out from that radical as a -1. Remember a while ago when we were separating them radicals, we said if it had a negative under there, we're going to bring it out as a -1. And then what am I going to turn that square root of -1 into?
An I.
An I. So that's going to give me an I square root of 47. So y'all, if this radical is negative and you can't do nothing with that number, you at least have to bring that negative out as a I. So that this will give me 1 plus or minus I square root of 47 all over 6. Now, here's the thing. On this problem, I actually got to go a little bit further because we call this a complex number because it's got a real part and an imaginary part. So when you got a complex number, they want you to separate it into 2 fractions. So you're going to put the 1 over 6 and get a 1 over 6 plus or minus. And then you're going to put the square root of 47 over 6. And then beside that, you can put your I. Now, if you want to put the I in front of the radical, it'll take that answer also. But this is what we call complex number form. You got the real number, then you got the imaginary number. And y'all, at that point, throw that in MathLab and be done. Now, if you want to write this twice, 1/6 plus square root of 47 over 6i, or 1/6 minus square root of 47 over 6i. So we'll do a couple more of these because I want y'all to get sort of good at seeing this. But just remember, if you got imaginary answers, they want them split apart, okay? All right, so what I'll do one more of these quadratic formulas, and then we'll take a break, and then we'll come back and play with that Pythagorean stuff. All righty, y'all. So this one will be like number 6. So number 5 is another one of those. Number 5 is like number 3. So this one has an f of x equals 3x squared minus a 7x minus 5. So for this one, A is 3, B is -7, C is -5. All right, so let's plug it in. We get x equals negative times b, which is -7, plus or minus our square root. B squared will be -7 squared minus 4 times A is 3 and C is -5. All that over 2 times my A, which is 3. All right, y'all, so that negative did its job again. It made that -7 into a +7, plus or minus. All right, y'all, -7 times -7 is 49. Over here on the right side, these 3 numbers are getting multiplied. I got 2 negatives, so that's going to make that side positive. Woo, that's going to be a big number. Let's see. 4 times 3 is 12. 12 times 5 is 60. All of this over 2 times 3, which is 6. All right, so now I can add the stuff under the radical. So 7 plus or minus square root. Y'all, let's see. 49 and 60, that is 109. All of that over a 6. So now the side work is going to be simplifying that square root of 109. So that's not dividing by 4, not an even number. Let's see if it'll divide by 9. Now, to check if it divides by 9, all you got to do is add these digits together. 1 and 9 is 10. So since that don't equal 9, it won't divide by 9s. Not dividing by 16. not dividing by 25. No, I don't think that thing's dividing by anything. We cannot simplify this. So guess what? That means our final answer is 7 plus or minus the square root of 109 over 6. Now, I don't have to split this one into 2 fractions because I don't have the i's in it, okay? So the trick is getting it to this radical and then seeing if that radical will go any further or not. If it don't go any further, stop and be done. Use the plus or minus instead of having to write this twice in MATLAB, okay? All right, y'all, so let me go back and pause this video. All right, let me get my screen shared here. All right, y'all, so 4.8 deals with applications of polynomial functions. And we're still playing with the quadratic functions only in this section, okay? So the first thing you got to know are a few things about when I graph these parabolas. So the zeros of a quadratic function are equal to the x value of the x-intercepts. Now remember, x-intercepts is where the graph crosses the x-axis. So this is another way to find solutions to a quadratic equation. If you were to graph it, you could look at the graph and see where that graph is crossing the x-axis at. If you can find that, that'll be the point that is the solutions to your quadratic equation, okay? So I'm going to go to the MATLAB to show you these 2 examples. So let me share my screen. All right, y'all, and then I'm going to make this graph a little bigger so we can see it. So y'all notice the first thing they want to know are the x-intercepts. Well, they got the dots where it's crossing the x-axis at. Now remember, the x-intercepts have to have a 0 for the y value when you put them in, and these got to look like ordered pairs. So the point to the left is on the x-axis at -3. So that point will be -3, 0. Close those parentheses and then do a comma. And then open the next parentheses for the second answer. And that's on the right side where that dot is. And it looks like that second dot is on the x-axis at 5. So that point will be 5, 0. Close your parentheses. So we're doing this so that y'all will realize that these x-intercepts, the x values will be the solutions. So you put enter on that one. And then okay. Now it says, what are the solutions? Well, the solutions will be the first x value, which was -3, comma, the second x value, which is 5. So that's all this exercise wants you to realize, is that those x values are the same as the solutions. So you're going to check that answer. All right, so this is on y'all. What are my x-intercepts? And I'll make this bigger. So y'all, any guesses on the x-intercept on the left?
-2.
So let's
And
see.
4.
So first one was what? -2, 0.
And then 4, 0.
And then 4, 0. So good job. So then you check that. All right, y'all. What are the solutions?
-2 and 4.
-2 and 4. So y'all, these two problems not bad. They just wanted y'all to realize that your x-intercepts, x value is the same as the solutions. So y'all, that's bringing us into some nice little word problems. So we only got 2 more word problems to do, but these are some dandy ones, okay? So the first one says a wire is stretched from the ground to the top of an antenna tower. All right, y'all, then they say, hey, the wire is 10 feet long. All right, then they say the height of the tower is 2 feet greater than the distance D from the tower's base to the end of the wire. Then it says find the distance D and the height of the tower. So we're finding 2 things on this. We're going to find this distance D and the height of this tower. So the best thing to do on this one is to sort of draw you a little picture. So I'm going to draw me an antenna tower here. So say this is my antenna tower. I got a wire stretched from the ground to the top of this tower. So I don't know where yet, but I got me a wire that's stretching from the ground to the top of that tower. So that's going to be my wire. And remember, that's my tower. I do know the wire is 10 feet long. So this wire is 10 feet long. Then it says this height of this tower over here, the height of the tower is 2 feet greater than the distance D from the tower's base to the end of the wire. So this right here, we don't know how long that is, but they're calling that D. So y'all, if this distance is D and this tower is 2 feet greater than that distance, to represent this side, I'm going to call this D plus 2. So the wire is 10 feet, and then this tower is 2 feet greater than the distance D, and distance D was the distance from the base of the tower to the end of the wire. Now, what we want y'all to realize on this is that this makes a triangle, and specifically, since that's a 90-degree angle here, this is what we call a right triangle. And there's a nice little formula that'll solve for the sides of this right triangle. So y'all, for this one, I'm going to use what we call the Pythagorean theorem. So do y'all remember the Pythagorean theorem?
A squared plus B squared equals C squared.
All righty, a squared plus b squared equals c squared. Now, the only stipulation on this is that the c squared side has to be the longest side over here. And y'all remember what we called that longest side?
Is it the
Starts with
the length? Sorry,
what starts with a H.
height.
Hypotenuse.
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 There you go. There you go. So, and that's always the side that's opposite from that little right triangle there, okay? So this always has to be C, the longest side. So what I'm going to do is plug in all this stuff for these letters. So A and B, it don't matter who A and B are. So I'm just going to let A be my D. So I'm going to get D squared plus my B side will be D plus 2 squared. That's going to equal our C squared, which is 10 squared. So now all we got to do is solve this thing for these D's. Now, D plus 2 squared, I'm going to solve that on the side here. Because D plus 2 squared, since you're squaring this whole thing, you got to write this twice and FOIL it. So that's going to be a D plus 2 times a D plus 2. Y'all, the biggest mistake I get in math, when people square this, they do D times D is D squared, and then they do 2 times 2 is 4. But they're missing the insides of this. You got to FOIL this thing, okay? So here we go. D times D is D squared. So I did that. Now I'm going to do D times 2 is a 2D. On the inside, I got 2 times D is 2D. And then at the end, 2 times 2 gives me 4. I'm going to add my like terms so that I get a D squared plus 2 and 2 give me 4D plus 4. I'm going to now replace that D plus 2 squared with all of this. So I got a D squared I'm bringing down. Then I'm going to put in my D squared plus 4D plus 4. And then y'all, 10 squared, 10 times 10 is 100. So y'all, the first thing I'm going to do, I got like terms on the left side. I'm going to add my like terms together. So 1 and 1 give me 2D squared plus 4D plus 4 equals my 100. Now remember, since this is quadratic with a squared term in it, I need a 0 over here. So to get a 0, I'm going to subtract my 100 from both sides. So let's see what we get. We get a 2D squared plus 4D. 4 minus 100 is a negative 96. That's now going to equal 0. So we're almost to the point where we're going to either factor this or we're going to use the quadratic formula. But y'all, I can make this a little bit smaller. Is there a number that I can divide all 4 of these by?
Two.
2. So if we want to make this smaller, since they all divide by 2, let's divide everybody by 2 and see what we get. So 2 divided by 2 gives me 1d squared. 4 divided by 2 gives me 2d minus 96 divided by 2 is 48. All that's going to equal 0. So y'all, at that point, we're about to factor this. D squared is a D and a D. Now remember, if you don't like factoring, use the quadratic formula. Remember, that's negative, so one of these is positive, one's negative. I need to find factors of 48 that will subtract and give me a 2. So let me play a 48. So 1 and 48, that's not working. 2 and 24, that's not working. 3 and 16, that's not working. What's next? 4 and 12, getting closer, but I don't get a 2 yet. So what's next? 6 and 8, and y'all look at that. 8 minus 6 will give me a 2. So my factors are going to be 6 and 8. The larger number 8 has to have the same sign as the middle. So the 8 will be positive, 6 will be negative. But y'all, like I said, if you don't like factoring, you can plug that thing into the quadratic formula, A, B, and C, and you'll get the same answers. So now I'm going to set both these equal to 0 and solve them for the D. So the first one, I'm going to subtract 8, and I get D is a negative 8. The second one, I'm going to add 6 to both sides, and I get D is a positive 6. So y'all, here's my question to y'all. How long is that D? And you got 2 numbers to pick from. But which one would be the distance in the real world?
6, because it wouldn't be a negative, right?
Yeah, we're looking at distance. We're not going to take these negative answers. We're going to kick them out. The only answer we want is a positive 6. So that means this D here is 6. So the D is 6. That's the distance. So what is the height of my tower? Well, y'all got me a 6 for the D, and they said the tower
8.
was D plus 2, so that is y'all getting an 8? Right, if this side's 6 and this tower's 2 feet taller, 6 plus 2 gives us 8. So you would put in 6 for the height of your tower. Then the second blank, D is 6. Then you would put in the height of the tower would be an 8. Then y'all watch this. If you want to check yourself, what does 10 squared equal?
100.
All righty. What does 6 squared equal?
36.
And then how about that 8? 8 times 8.
64.
And y'all look at this. 36 plus 64 is 100. Well, guess what? Side C was 100 if you squared it. So that works out. 6 squared plus 8 squared equals 10 squared. But y'all, this is what Math Lab wants. It wants the 6 and the 8. And you're going to get a negative answer and a positive answer when you do this. But you got to kick out the negative answer because we're talking about a real world situation here, okay? All right, y'all, let me let y'all write that and then we'll move on. Now we'll say this. The next one I do, put a star by it. All right, let me move this back up. All right, so for this example, I'd put a star by it because you're going to see this example on your test. You'll even see this example on your final exam. So another word problem. So it says the foot of an extension ladder is 7 foot from a wall. Then it says the height that the ladder reaches on the wall and the length of the ladder are consecutive integers.
That just means they're equal.
Consecutive integers. So,
Yes.
So consecutive integers means things in a row, like 5, 6, and 7. Those would be consecutive integers because they're in a row. Does that make sense?
Yes.
So now they want to know how long is the ladder. So they only want to know one thing on this one is how long is that ladder? So here's our wall. So I'm going to draw my wall here. Then I got a ladder leaning up against that wall. Now, first thing I know, it tells me that the foot of this ladder is 7 feet from the wall. So this little distance here is going to be 7 feet. Now they're saying, hey, the height on this wall that this ladder reaches and the length of this ladder are consecutive integers. So y'all, if I let this height equal X, what can I use to represent the length of the ladder? Well, if they're consecutive integers, how do you go from one number to the next?
Would you use Y?
Well, think about this. So say X was 5. What would I do to the 5 to get to my next number?
Add 1?
Add 1. So I don't know this height, but I know they're consecutive integers. So this side will be X plus 1. That way, if this one gives me 8, this one will give me 9. If this gives me 15, this one will give me 16. So that's what they mean by consecutive integers, okay? But y'all, guess what I got here? I got another one of those nice little right triangles, which means I'm going to use the Pythagorean theorem again. And we know that a squared plus b squared is going to equal c squared. Let me ask y'all this. Which side will be my c?
X plus 1.
X plus 1. So that's my c, and then a and b don't matter, okay? So I usually just go in order, and I'll let this be my a here maybe, and x will be my b. So y'all, let's plug in. A is 7, so that's going to be 7 squared plus b, which is x, so that's going to be x squared. That's going to equal our c squared, which is x plus 1 squared. So on the side, I'm going to have to figure out what the x plus 1 squared is. And remember, we're going to write that twice. X plus 1 times x plus 1. All right, so same type of thing. Let's spoil x times x is x squared. X times 1 is a 1x. On the inside, 1 times x is a 1x. And then at the end, 1 times 1 is 1. Once again, I'm going to add like terms. So I end up with an x squared. 1 and 1 give me 2x plus our 1 at the end. So now we can replace the right side with this. So first of all, 7 squared. What do y'all got? 7 times 7? So I get a 49 plus my x squared. That's going to equal the right side, which is now x squared plus 2x plus 1. And y'all remember, these are quadratic at the moment. So since they're quadratic at the moment, I would try to get all the x squareds on one side. But y'all look, when I try to move these x squareds, what's going to happen to those? Well, over here, I got my 49. Look at that. Those x squareds cancel. They're going on the left side. Well, guess what on the right side? X squared and negative x squared. They cancel. All that's left over here is the 2x plus 1. So y'all, if you got the same thing on both sides and it's the same sign, when you move them, they're going to cancel out everywhere. So this is no longer quadratic because we don't have any x squared terms. So all I got to do at this point is solve for that x. I don't even need to get everything on one side equal to 0. I just need to get my x on one side, numbers on the other, and be done. So we want to get the 2x by itself. So that 1 is going to be subtracted from both sides. So 49 minus 1 will give me 48 equal to our 2x. And if you notice, since the x squared stuff went away, this will only give me one answer. I'm not going to get a negative answer and a positive answer on this one. Okay. All right, that's 2x. Turn that into 1x. Divide both sides by 2. So y'all look at that. 48 divided by 2 is 24. 2 divided by 2 makes that a 1x. So the question of the day, how long is my ladder? What are y'all putting?
25.
24 feet long.
Oh, so I got somebody. Because remember, here's my x. And x is 24. So look at your
Oh,
ladder.
25.
25. There you go. So you got to come in and do your 24 plus 1. And that ladder is actually 25. There you go. So y'all, this one you can't quit when you get to x, because remember the x is just the wall. You got to come back and add that 1 to get that ladder. So that's where they get a lot of people. A lot of people, once they get that x, they put in 24 and they're done. But don't do that, because it's going to miss it if you don't add that 1 to it. Okay. All righty, y'all. Questions on that? All righty. So let me stop this share.
I have a question. So you said it doesn't matter which one A or B is?
Right.
Okay.
Yeah, I could have made my A to X and my B to 7. Since they're on that same side, it don't matter. The only side that matters is that long side has to be the C.
Okay.
Okay. All righty, questions, anybody? So let me go look at Math Lab real quick. So y'all, I might play with a few examples out of 7.4 support. Just to show y'all what's going on that. So let me share my support screen. All right, so I'm going to write this problem down real quick. I got 11R plus 6. And then in the second parentheses, 5R minus 15 equals 0. So this support was just getting you ready for the problems where I factored earlier. And then this one's already factored and in parentheses. So they was just wanting you to realize that if you got stuff factored equal to 0, you would set both these factors equal to 0 to solve. So like my first one, I'm going to subtract 6. I get 11R equals negative 6. Then I would divide both sides by 11. So those cancel, giving me 1R. Can't do nothing with that, so that's going to stay a negative 6 over 11. And then the second one, you would add 15 to solve it. So I'm going to get my 5R equals 15, and then divide by 5. So that I get, that makes a 1R equal 3. So this problem was just getting you ready for section 7.4 where you had to factor. So y'all, let me see the second problem they got. Alrighty, also this is a b squared minus 4b minus 21 equals 0. So see, the first one they already had factored. Now, starting at number 2, you got to factor them and then solve them. So factoring that, we're going to put these in parentheses. B squared is a B and a B. Now remember, that last sign's negative. So one of these is positive, one is negative. Now, since the last one's negative, can y'all find me any factors of 21 that'll subtract to give me a 4?
7 and 3.
7 and 3. Now remember, 7's the larger number, has to be negative like the middle, and then the 3 will be the positive one. So if you add 3 and negative 7, they equal negative 4. And then y'all, the rest of this.
Could you explain why you put the 3 and 7 there again?
Okay, so the only way to get 21 is 1 times 21 and 3 times 7. So what I look at, these are factors of 21. Since there's a minus in front of that 21, that's telling me to find 2 of these numbers here that I can subtract that'll equal a 4. So 21 minus 1, that equaled 20, so that wasn't going to work. But
So you just put the 7 behind the negative because...
Because the larger of these numbers, when you write them in as factors, the larger number has to have the same sign as that middle 4. So since that 4 is negative, the larger number has to be negative. That way, when you add them, 3 and negative 7, you get a negative 4. Now, if I'd have made the 3 negative and the 7 positive, a +7 and -3 would have gave me a +4 instead of a -4. Okay.
Okay.
All right, y'all. And the rest of this, really, to get the answers, all we're doing is changing these signs. Because here I got to subtract 3, and I get b is a -3. On this one, I'm going to add 7, and I get b equals a +7. All right, let me go back and see what we want next.
When you write your answer on there, do you just put -3, 7, and then the same for number 1?
That's it.
Okay.
All right, y'all. Now, these ones are a little trickier when they got a number in the front, but I'm about to show y'all what I do to these. When you got a number in the front, we cannot use the factors of the last number. If you got a number in front other than a 1, what you got to do, your first step is to multiply 2 times 26. And 2 times 26 gives me 52. So now, remember this, if you got a number in front, we got to multiply by the last number to get 52. Now, what we want are factors of 52. Now, remember, this is a plus. So I want factors of 52 that add to equal 17.
You can't see your
Yeah, I
screen.
can't see your screen.
Oh, did I not share my screen? My bad. All righty, so I start out with 2x squared minus 17x plus 26 equals 0. So since you got a number in front other than a 1, you got to multiply that 2 times that 26. So when I multiply 2 times 26, I get 52. So we temporarily got to treat 52 like it's the last number. So I want factors of this 52 that add to equal 17 in the middle. So y'all, let's find some factors of 52. We got 1 times 52. Those don't add to get me 17. I got 2 times 26. Well, y'all, those don't add to get me 17. So what's next? 4 times 13 equals 52. And y'all, guess what? 4 plus 13 equals 17.
I thought there was a way to do that on the calculator. I remember my last teacher showing me, but I don't remember what it was. Like to get your factors like that?
Um,
What was the way? I just don't remember.
so let's see. Oh, I'm trying to think. Some of them use these apps. Let me see if it's the apps you're talking about. If I go down to the apps, oh, mine ain't got it on this one. That's probably what they were doing, some kind of a solver or something. You don't remember where they was going to get them at?
I thought it was the well, I have the CE. I don't know which one you're working off of, but
Oh yeah, they're
Um,
both about the same.
I thought
me
it
ask
was
you
gonna be
this.
like the LCM or the GCD on here, but I don't remember which one it was.
Oh, what class was it?
It was the foundations of algebra.
And who was your teacher?
Kristen McConnell.
Okay, so yeah, I'm not sure what she's doing on those.
I'll have to try to remember.
Now, if you had programs on it, I could go to these programs. And I got quad on this, and so let me try my other calculator. I think all I got is quad on mine. Yeah, nothing no missing. So let me try one more thing, what she might have been doing. Okay, not there. So one more place. Let me try one more place. Oh, some of these got it and some don't. Let me try my catalog. I'm gonna go to my S's real quick. Hmm. I'm not sure what she was doing, but I will say, if you want to find these factors, remember I said that we can solve these by graphing. So let me show you another way. So let me put that in here. 2. Are y'all seeing my calculator?
No.
Okay, so let me share my screen with my calculator. All right, so what I'm going to do is put in that equation, 2x squared minus 17x plus 26. Now, if you do this way on these problems, this will give you the actual 2 answers. So watch this. I'm going to graph it. So the trick is just figuring out what these 2 numbers are. So what I'm going to do is go to my table, because I'm looking for y values that are 0. So let me fix my mode. I'm still floating. All right, now let me go back. All right, go to my table. So you see where that y value 0 is on the 2? That means one of these answers is a 2. But if you go to there, you're not seeing the other answer, because the other answer is probably a fraction. And since my first number was for a 2, what I can do on that is fix my table. I'm going to hit second window. And you see where it says triangle table? That means the change in your table. So if your first number is a 2, you want to make this a 1/2. If your first number was a 3, you would make that a 1/3. 4, you would make that a 1/4, and so on. If you do that, watch what it'll do. And I go back to my table by hitting second graph. Now, these numbers are getting larger that way, so I'm going to go the other way. So at 0, let me find me some zeros here. So there's a 0 at 2 still. So the other point went to the right. And y'all look at that. At 6.5, I got my second 0. So if needed, you can graph it and find where your y values are 0. That'll actually give you your solutions, okay? Now, MathLab, you'd probably have to turn that 6.5 into a decimal by hitting math and enter twice. Whoops, let me get off that screen. So 6.5.
I know how to find the factors on a calculator if you wanted me to tell you.
Okay, so what are y'all using?
Okay, so what you do, well, on a TI-84 plus, you're gonna hit y equals,
Uh-huh.
and then you just type in whatever number you're trying to factor and hit divided by x, and then you're just gonna hit second and table, and that will pull up all of your factors.
Oh, she's going old school then. Okay. So she's doing it like this. And then going to my table.
Yeah, I think that's probably how it was.
And I know that's not like an app or anything like that, but
Uh-huh.
if that just helps
So let
me.
me set my window back to going by ones again, and I'll show y'all what she's talking about. So let me make mine go back to 1 here instead of halves. All right, y'all. So she's talking about when you go to the table. I don't want to start at 3.5. I'm going to start at 0. Okay. All righty. So I'll quit that screen. Now I'm going to go to the table by hitting second graph. So the factors are 1 times 52, 2 times 26. I would skip the decimal. 4 times 13. Okay, so she's going old school on these. And then the next factor would be 13 times 4. So it's starting to repeat them, just putting them in different order. Oh, I didn't know Mo McConnell. That's good though, because yeah, and y'all all you got to do is start at your zero's not going to work. So start at 1 and 52, 2 and 26, 4 and 13, and so on. Okay, thanks for sharing that because that helps. All right, so I'm going to use 4 and 13. So let me show y'all a trick on this. So remember, those two answers we got were what, 2 and 6/5 or something like that? I think. But y'all, when you got these two numbers, notice they're both going to be negative like the first number. So I'm going to have an x minus and an x minus. My two numbers are 4 and 13. But here's the trick. Since we multiplied by 2 to get that last number, when you find both these numbers, you got to divide both them by that 2. So y'all watch what happens. This is going to give me x minus 4 divided by 2 is 2. So that one's going to give me that positive 2 later. Now, can you simplify that? No. So that's going to stay x minus 13 halves. Now remember, all these are equal to 0, right? So solve both these by setting them equal to 0. So guess what? Add 2 and be done. Add 13 halves to both sides and be done. And guess what? This 13 halves, if you take that 6.5 we got a while ago, oh yeah, that was a 6.5. But if you take this 13 halves, it'll turn into a 6.5 decimal form, which means the 6.5 decimal form will turn into a 13 halves on your calculator. So let's go verify that. Go ahead, 6.5. Remember, if I do math and enter twice, there's my 13 halves. Okay, so they're tricky when you got a number in the front. All right, y'all. Now I'm going to go through there and see if there's any more with them numbers in the front. All right, y'all. Let's see what we would do to this one. I'm going to write this down real quick. 2x squared minus 14 equals 0. So this one can actually be solved a little bit nicer than what we've been using. Anytime you got an x squared term and a number, but you don't have that x in the middle, watch how we can solve this. I'm going to add 14 to both sides. And this is technically the third way you can solve these. So bring down to 2x squared. 14's canceled over here. This side, I now have a 14. Now I'm going to make this a single x squared by dividing both sides by 2. So y'all, at the moment, the 2's cancel. I got x squared equals 14 divided by 2 is 7. So y'all, let me ask you this, and it sort of goes back to what we did on the first test when we was doing those inverses. But how can I turn an x squared into just an x? Do y'all
Square
remember
root.
what? Oh, what'd you just say?
I think square root.
Okay, I think you're right. Good job. So we're going to take a square root of both sides. So y'all, the square root of x squared is an x. Now remember, we got to put a plus or minus over here. Anytime we do square roots, we got to consider both the positive and negative answers. And y'all, can we simplify that square root of 7? No, it don't have no 4s in it, 9s or anything like that. So that's just going to stay a plus or minus square root of 7. So they're not too bad. That's the third method I would use to solve these, okay? Is square roots.
Why'd you put the plus or minus on that one?
Because anytime you do a square root, it takes 2 positives to make that, or it could be 2 negatives. So a negative square root of 7 times a negative square root of 7. Okay, so just remember, just like when I had a 4 under here, 2 times 2 is 4, negative 2 times negative 2 is 4. So since, and remember, that 2 on that exponent tells you you got to get 2 answers, and that's what that plus or minus is doing. So we always got to take into account that square roots can be negative or positive, okay? So on that one, I would just put in that plus or minus, grab that radical, put in my 7, and then check those answers. All right, y'all, let me see what they got next. So that's the same thing. Divide both sides by 4, get the x squared by itself, and then do the square roots. So hell, that's going to end up with a 7 too, wouldn't it? All right, let's try this one. 4x squared plus a 20 equals 0. All right, so I'm going to share that. So x squared again, there's no x. So I'm going to get the x squared by itself and do the square root stuff. So I'm going to subtract 20. So I get 4x squared equals a negative 20. Divide both sides by 4. So that my x squared equals a negative 5. Then once again, we're going to take square roots of both sides. So the x squared will come out as an x. This is going to be a plus or minus. Can we do anything to the square root of that negative 5? Y'all, there's at least one thing there's at least one thing y'all got to do though.
The 1.
Exactly. I can't leave that negative under the radical.
So negative 5i or 5i.
Well, how about a negative plus or minus I square root of 5? Or you could do plus or minus square root of 5, and then on the outside, put your I. So bring them negatives out as the I, because remember, that equals a square root of negative 1, and the square root of negative 1 is always going to be the I. So we would put that in. So I'll show you. You can do the, but they all got to be plus or minus. So plus or minus, square root, put in the 5, but arrow out of that thing before you put that I, okay? Or you can put the I in front. That way it's not under the radical. So y'all watch what happens. Whoops. Watch what happens if I put the I underneath. If I put the I underneath and I check that answer, it's going to mark me wrong. So come back up here. Go back underneath. And then delete that I and go outside the radical and put your I. If you're outside the radical with the I, then it'll take that answer, okay?
So you just use the regular I on your keyboard?
Yeah, I just used the I on my keyboard, but it should give you, I think, does it not give you the I down there on the thing? Let me
I
hit,
didn't see one.
so let me hit similar. Once I click into blank, oh, you might have to
Yeah,
hit, if you hit
it do if
more,
you, yeah, if you hit more.
but I just use the little I on my keyboard, it's quicker. All right, same thing there. I would subtract 49. This is like we did a while ago. What are the x-intercepts? What are the zeros? Just remember the x-intercepts have to have a number, then zero. So that looks like what? -1, -2. So that would be -4, 0. On the other side, it's 1, 2, 3, 4, 5, 0. And then the zeros would be the -4 and the 5. So that's just doing sort of what we did in the 4.8. And I think that's all that the rest of this is doing. Now, y'all, here's the trick on this one. I got a 5x² plus 6x equals a -2. And they want you to use the quadratic formula on that. So the trick on this one, that -2 is sitting where I need a 0 at. Remember, when you use the quad formula or factor, everything has to be on one side equal to 0. So on this one, you would have to add 2 to both sides so that you get 5x² plus 6x plus 2 is all equal to 0. At that point, plug all this into your quadratic formula and get your 2 answers. So my A is 5, B is 6, C would be 2. So here we go. X equals -b, which is 6, plus or minus square root b squared. So that'd be 6 squared minus 4. A is 5, C is 2, all over 2 times your A, which is 5. All right, so that makes that a -6, plus or minus. All right, under the radical, 36 is what I get when I square the 6. Notice this side only has one negative, so that side will stay negative. 4 times 5 is 20. 20 times 2 is 40. All over 2 times 5, which is 10. So we're getting close. We just got to figure out the rest of this radical. So bring down your -6, plus or minus. Oh, and y'all look at that. 36 minus 40 is going to give me a -4 all over my 10. So y'all, what we need to do on the side is figure out what we can do with that square root of -4. So what does a square root of -4 simplify to?
Square root of 4i.
Oh, and you can even go further. What is the square root of 4?
Oh, wait, 2. Sorry.
So 2, and then that I you told me. So if they're perfect squares like the 4 and it's negative, it's just going to come out as a single number and the I. So what we're going to do is now we got -6 plus or minus 2i over 10. I got 3 outside numbers. What can I divide all 3 of them numbers by?
2.
Okay, so dividing by 2, I get a -3 plus or minus a I over 5. So remember, I had to do all the numbers. Now remember, if they want these in, so let me go back and check and see what they're saying on our answer blank. So notice, type your answer in the form of A plus BI. So they want me to separate my real number from the imaginary. So the real part will be -3 divided by 5. Then I'm going to use my plus or minus. Ooh, where is it at? I've seen it a while ago. Let me do less and see if it'll show it. Okay, there's my plus or minus. And then my second one was I over 5, which I could make that a 1 divided by 5, and then come and put my I. So if you get imaginary answers, you got to separate the first fraction from the second fraction on those, okay? All right, y'all, then it makes you what? Check your answer and you move on. All right, so I just wanted to give y'all a little taste of the 7-4. And let me see what 4-8 had on its support. Support for 4-8. I think it's more foiling and stuff. All right, y'all. So I'm going to share the screen now with the foiling stuff. And we'll just see if y'all think y'all want help on this or not. So let me go to the problem. So W minus 5D squared. To FOIL that, y'all would write that twice. W minus 5D times W minus 5D. Anyone need help doing that? All right, so I'm just going to go through some of these and see what we think. Second one, same thing, x squared plus 5. That'll be x squared plus 5 times x squared plus 5. Just remember when you multiply the x squared times the x squared, add those exponents. All right, y'all, number 3. So let me see what y'all think about this. Let me move this stuff out of my way. So y'all, can the number 0 be a solution to a quadratic equation?
It's gonna be A.
Oh, so you're so close. But remember, at the end, it's saying the solution is never 0. So let's go to D and look at D. D said the sentence is true in order to obtain a 0 on one side of the equation. So that's okay. So let's see. Oh, so they're saying the number 0 is never a solution. That's false. 0 can be a solution, okay? So let's see what they're saying. The number 0 can be a solution if the number is substituted into the original equation and the result is a true statement, then that number is a solution. So we would definitely go with B. And y'all just think about this. Let me write one down and I'll show you what I'm talking about. So I'm gonna go to my pad. Say I had something like this. Let me move this back up. So what if I had 5x squared plus, say, what I want here. How about 15x equals 0? Now, although I don't have a number at the end, this is still quadratic because I got an x squared term in it. So when I got two terms like this, and they're both got x's in them, the way I solve this is by factoring out a greatest common factor. So the greatest common factor between a 5x squared and a 15x would be a 5x. So if you factored out a 5x from 5x squared, that's going to leave you a x, plus if you factor a 5x out of 15x, well, 15 divided by 5 leaves me a 3. So notice I got two factors now. So I would set 5x equal to 0, x plus 3 equal to 0. So y'all solving this first one, we just divide both sides by 5. And guess what? I get x is a 0. So if you put a 0 here, 5 times 0 is 0. 0 here, 15 times 0 is 0. And 0 plus 0 equals 0. So 0 can be an answer. And in your second one, you would subtract 3 and get a -3. So if you put a -3 in, -3 squared is 9. 9 times 5 is 45. 15 times -3 is -45. 45 and -45 equals 0. So both these answers check, but notice 0 can be a solution, okay? So where was we? So we're going to go to that. We're going to pick that one, because if we plug it in, we get a true statement. All right, y'all, let me see what 4 is doing. Also, that one you would solve just like I did. So let's see what y'all do to this. W squared plus 5w equals 0. Now remember, two terms both have a w. So what you want to do to that is factor out the greatest common factor. So what's the biggest thing that a w squared and a 5w have in common? Well, they don't have numbers in common.
W.
A w, there you go. So if you take a w out from the w squared, you're left with a w. If you take the 5w, divide out that w, you're left with the 5. And then at this point, y'all set both these factors equal to 0. Well, that one's done. That means w equals 0. If I put a 0 squared plus 5 times 0 is 0. 0 plus 0 is 0. So the 0 works. And then here you subtract 5 and get w as a -5. So -5 squared is 25. 5 times -5 is a -25. 25, -25 equals 0. So both them answers work. So on that one, you're going to come in, put in your 0, comma, -5. All right, y'all, what's that? A t squared equals 16. All right, so that's on y'all. So t squared equals. Oh, so what'd you do to that?
The square root.
Yeah, anytime you got a variable squared in a number, do the square root to it. All right, so what was your answers?
4.
Or remember, you got to give me two answers.
4 and 0.
Oh, well, let's see. 0 squared, not going to give me 16. You got the right answer. You just don't got both versions of it.
Plus or minus 4?
Plus or minus 4. There you go. Because let me show y'all what's going to happen. If you come on Math Lab and you only put in a 4 and you check that, guess what? You're going to miss it. You got to account for the -4 also. So if you come up here and you did 4, comma, -4, and you hit enter, you'll get a good, fantastic. Now, if you don't want to write it twice, then you could have used the plus or minus in front of your 4, okay? All right, y'all, and then there's one more that's on this support, so I'll just play with this. So what is that? A 50 plus 5b minus b squared equals 0. So let's go back to our pad. And let me pull this up. Now, the first thing I would do to that, I would put this thing in the right order. I'm going to put my b squared first. So it's a negative b squared. Then I'll put my plus 5b. Then I'll put my plus 50 and set all this equal to 0. Now, we always want the b squared term to be positive. So if your first number is negative, you want to come in and divide everybody by -1. Because you want this to be positive. So negative divided by negative makes that a b squared minus 5b minus the 50, all equal to 0. So by dividing by -1, that changes everybody's sign. All righty, y'all, this one I think will actually factor. So let's see if we can factor this. B squared is a B and a B. The last number is negative, so one of these will be positive, one of these will be negative. So now let's do that little trick. So say we don't know the factors of 50. I'm going to show you all a trick she was talking about a while ago. So let me find my calculator. Remember, we're going to go to y equals and clear that. Now remember, we said we're going to take our 50 and we're going to divide by our x. And then we're just going to go look at that table by hitting second graph. So 1 times 50 is a factor, but that don't subtract to get me a 5. 2 times 25 is a factor, but that don't subtract and give me that 5. Y'all right here, 5 and 10 does subtract to get me a 5. So that's the factors we're going to use. So let's go back to our pad. We know it's going to be 5 and 10. So y'all, if you was paying attention earlier, which of these two numbers am I going to make negative and which one's going to be positive? Oh, y'all, let me get y'all.
10 is gonna
The
be
5 is gonna be
Yeah.
There you go. So the 10's got to be negative because it's my larger number. And then the 5 is positive. And if you add that, 5 and -10 equal -5. 5 times -10 equals -50. All right, y'all, the rest of this is just solving for the b. So here we subtract 5. I get b's a -5. Here I'll add 10. And I'll get b is a +10. And I'll tell you what, when there's not a number in front of this b squared, graphing it'll get you to 2 answers really quick. So watch this. I'm going to go to y equals. Let me clear that out. All right, I'm going to go to y equals. I'm going to clear that out. And I'm going to put in, instead of b's, I'm using x's. So I got a x squared minus 5x minus 50. So watch this when I graph it. So I see where the 2 points are. And look, that looks like that's at -1, -2, -3, negative. That one's at -5, which was one of my answers. And if you walk over here, this one will be at +10. And if you want to verify that, hit second graph and look at the table. So let's see, we got to go to -5 up this way. There's my first 0 at -5. And then if I come down looking for my other y 0, I get it at +10. So graphing is a nice way that you can also sort of figure out what these solutions are, okay? All right, y'all. So that's what kind of support's coming on this, and it will just get you ready for being able being able to FOIL stuff and factor stuff. And we learned 3 ways to solve quadratics. That was by factoring, quadratic formula, and if you don't have that x term, using the square roots. But y'all, this stuff is a little better than all that graphing, right? All righty, y'all. So let me see. I'm going to quit this recording.